Let's go then and start and have a look at the motor product range. As you all probably know, motors started in Everel a long time ago with the GM brand. At GM, they started producing motors for domestic ventilation quite a few years ago. And then by acquiring the GM brand, Everel further developed these motors and this concept. At the beginning, like I said, it was the shaded pole motor, mostly used for applications such internal domestic air extraction units, typically for bathrooms, for example. And after that, by further developing the product and its application, we extended these motors also to, for instance, electrical ovens, typical application, the ventilation of the ovens for both cooling the electronics, for instance, or cooling the front door. At the end of this path, there is a further evolution of the Bldc motor, which generated the EC Bldc version. By keeping the same motor structure, an electronic driver was developed and a new motor was introduced by combining the simple mechanical structure of the 52 and 58 millimeter shaded pole motors and the more refined possibilities of controlling the motor itself given by the electronic driver. Last development is a new family of Bldc motors. It's a three-phase motor, quite bigger than the 58. It's an 80 millimeter diameter, and which is designed to feature a quite higher power output, which I will talk about later in this presentation. On the difference between the shaded pole motor and the electronic controlled or electronically commuted brushless motor. On one end, the shaded pole motor is definitely the cheapest motor, electrical motor that you may have on the market. It's being so simple, it has the possibility to work at quite high temperatures. See the ovens applications that we mentioned before. On the other hand, of course, it has a quite low efficiency, so it's typically used for very low power applications where the efficiency itself is not that important, has a limited possibility in terms of customization, and has, of course, a limited output performance. By switching to the EC brushless concept, you get for sure a more expensive product, but you get a much higher efficiency. So again, if the application is critical from the point of view of the energy consumption, this is definitely a motor that needs to be considered. And it is highly customizable in terms of performance, because performance and adaptation means basically firmware adaptation. So no hardware changes, only changes in the software. It also has a big capability to be controlled via an external signal, and its sense of rotation can be inverted by the electronic controller that gives the signal to the motor itself. Quickly, just an overview on the mechanical structure of the shaded pole motor. A shaded pole motor belongs to the so-called family of the AC induction motors. So there is a electromagnetic field which is induced in the main coil, in the main winding in the stator. This magnetic field interacts with the rotor. The rotor has the so-called squirrel cage structure, obtained by die casting aluminium onto a sheet metal structure. And by the interaction of this electromagnetic field with the rotor, you get the torque that actually turns the rotor and gives you the output power and torque. Typically, these motors are thermally protected by means of a thermofuse or a thermostat. Sometimes for lower powers, they are intrinsically protected by the resistance itself of the main coil. Here is an overview of the basic elements of the shaded pole motor. So this is an exploded view. You see that there is what we call the pole. Onto the pole, we assemble the main windings. And the pole with the pre-assembled windings is pressed into the collar in order to obtain the stator, the complete stator. Once you have the stator, you put the rotor inside and you pack everything together by assembling the front and rear flange. Just to cut it very short and to put this in a very simple way. Some data, some figures about the shaded pole motors. They come in both low voltage and high voltage versions, so their voltage supply can vary between the 12 volt AC to 240 volt AC, of course. Frequency doesn't really matter. The only thing that changes it's the speed at which the motor is running, because the speed of AC motors strictly depends on the frequency of DC current they are fed with. Rotation can be chosen when configuring the motor in both directions. It cannot change on the same motor during its functioning. The efficiency, like I said, is quite low. It's up to 18%, which is a value only acceptable where the absolute values of power is quite low. Otherwise, it would be a waste of energy. It's only available in a non-protected IP class, so IP00. Insulation class, I'm talking about thermal insulation class, can be F, that means 155 degrees on the coils, or H, 180 degrees. It is VDE certified and can be assembled by using either sleeve bearings or ball bearings. The latter guarantee, of course, a much longer life, up to 30,000 hours. And they are also preferred when the noise level is very important, typically in ventilation. There are a number of connecting wires available, both in terms of section or insulation material. The stack height is available in a number of dimensions, ranging from 12 millimeters up to 35 millimeters on both diameters, with some limitation, as you can see. There is a number of different options for the thermal protection, like mentioned before. You can have a thermofuse, you can have a thermostat, you can have simply impedance protected winding, so no additional component. Also, the flanges can be available in different shapes and designs. So same as the shaft, which can have a different finish in order to match with the requirements of the application and typically of the fan, which is assembled on the shaft itself. Quick look to some of the solutions. Everel offer not only the motor itself, but the motor typically assembled with a fan, like in the case of these ventilation blowers or axial blowers. Or it could be a fan plus a housing. So it's a more complete ventilation unit typically used on the oven systems, like the one on the lower row of pictures, or the dishwasher ventilation systems. So it's more than not only the motor itself, but rather a system and assembly that implements also some plastic parts, fans, and so on. Applications, talking about the shaded pole here. Air extraction units are for sure the first application to play. Typically, like I said, air extraction units for bathrooms or small units for domestic uses. Baking oven ventilation, very big and important application for Everel. So ovens where the fan is meant to cool down either the electronics or the front door. fan heaters, where typically fan is combined also with heaters, electrical heaters, humidifiers, dishwashers, air cleaners, thermoconvectors, all these applications which also need an airflow to achieve their function. And in this case, the shaded pole motor is driving a fan, which can be a tangential fan, for instance, for thermoconvectors, or it could be an actual fan for some other applications shown on this page. We go now to the EC Bldc motors. They are available mostly in the 58mm diameter size. This size has also an IP65 version. That means there is a plastic cover which has been designed to wrap up the motor and to guarantee the motor to be watertight and protected also for dust. IP65 means that you have a quite high resistance against water pressure jets. There is also the possibility to get the Bldc motor on the 52 size, and under development, in a quite advanced state of design and development, we have the 80mm Bldc motor, which guarantees a quite higher power output, around about over 100 watts on the shaft. A few words, a simple description of the working principle of the Bldc motor. The Bldc motor is a permanent magnet type of motor. That means you don't have the squirrel cage rotor that I described very quickly about the AC motor, so the shaded pole motor before, but you have a magnet on the rotor itself with two poles. So everything is based on the unlike pole attracting each other and the like poles repulsing each other. So you have on the stator a magnetic field which changes its direction by inverting the sense of direction of the current in it, and by doing this you switch from attraction to repulsion on the rotor. And by doing that, you generate a force, which then translates into a torque, the torque which generates the rotation of the rotor itself. This concept is now shown with the physical construction of our Bldc motor. It's a two-pole motor. So you see North Pole attracted by the South Pole in the stator. And then you go like that. In the second row, in the lower row, you see that the polarity of the stator is inverted, and this is done by the electronics, so that what was attraction then is repulsion, and these dynamics generate the rotation of the motor. This is a quick exploded view of the Bldc motor, just to show how it is constructed. As you can see, the basic structure is very, very similar to the shaded pole motor. In fact, it has the same stator and the same windings. Only, like I said before, you have changed and replaced the shaft with a new shaft featuring a rotor, a magnetic rotor. And on the rear of the motor itself, you have a plastic rear flange, which also acts as a supporter for the PCB, for the electronic PCB that drives the motor. It is closed by a rear plastic cover. A few figures about the Bldc motor in 58mm diameter. Again, 12mm to 12 volts to 240 volts. Similar indication in terms of dimension, and the different finishing on the shaft and everything. The peculiarity of this motor is the possibility to be customized a lot in terms of firmware, basically. Here is a table showing some of the typical values in terms of power consumption and power output. As you can see, this table shows the much higher efficiency of the Bldc motor that can go higher than 40%. And of course, this is very important where the efficiency is a factor or where the needed mechanical power is higher than the lowest values that the shaded pole motor can guarantee. These values may vary quite a lot depending on the application, on the temperature, on the boundary condition, and so on. So that's why we typically customize a lot our motors in the real customer application. In the end of this overview, some indications about the new motor which is being developed. It's an 80 millimeter rotor diameter, has a different concept in terms of function, principle, and controller. It's a three-phase motor. It can deliver a power up to over 100 watts with a power consumption that in some applications can reach up to 200 watts. The efficiency, the typical efficiency is up to 80%, so it's much higher than its smaller brother, the 58 millimeter motor. Here a quick overview of the assembly of this motor, a rear and a front flange in aluminum, packing everything, so a permanent magnet rotor, once again, a stator, which is much more complex. It's 9 winding instead of 2, and a 6-pole rotor, which is assembled inside. Some applications, again, typical similar application to what was shown before for the shaded pole motors. Only the difference is that in these cases, these applications have higher requirements in terms of efficiency, in terms of power, because the Bldc motors are much more efficient and can deliver a much higher power output on the shaft. So again, air extraction units, humidifiers, air cleaners, centrifugal blower, and burners, very important application that we are also investigating. This overview table just gives an indication of the potential application. So the shaded pole motors can be used for oven ventilation, for extraction units, tangential blowers. The Bldc, not for ovens because of the temperature limitation, but it can be used for the same application. Typically, the Bldc motors are used on tangential blowers and centrifugal fans. The Bldc 80 millimeter motor also has the possibility of being used on cooker hoods, where this size of motor is more or less the typical motor size for this kind of application. This is a quick overview on the motor subjects. Of course, I'm available for any further question or request that you may have. Thank you very much.